as I was thinking about the workshop, I decided to take a bit more of a sort of management and design perspective, and ended up generating more questions than I have answers. So hopefully that's okay. I know you said we should send you some questions. They will be coming throughout the presentation, and we can see if we want to pick up any of them up during the discussion afterwards. So I do my work at Stanford largely in the context of CISFE, the Center for Integrated Facility Engineering, where we really look at how can we digitalize and integrate the different phases, the perspectives of the different disciplines, the different systems that we have in a building and in a number of buildings, neighborhoods, and so on. And so across different scales. And for that, this network of building owners, engineering, construction companies, and technology providers is very helpful. So just to give you a little background, and as you said, the questions we address really span design, construction, building operation, the feedback loops, really broadly speaking. How I characterize our work is you are here today making a decision that relates to a building or infrastructure system. And you should be able to do that by understanding the history better and by understanding the possible futures better. And so we work basically, broadly speaking, at three areas here. How do we understand the performance that we have achieved in the past better, and what were drivers of that performance? How can we simulate possible futures and create, at least based on what we know today, an optimal design? And how do we manage that really much more data and tool intensive set of methods? Companies here don't have really a method of managing working in the context of the built environment with these emerging methods. So broadly speaking, that's what we work on. And of course, building energy efficiency is absolutely a critical element of that. And this has been brought up many times, but this is, as I reflect back, even 10 years or so, this is what I've seen as a new thing, that we can finally understand demand and supply. I would say up to 10 years ago, the majority of people worked on one or the other side of things, and they didn't really meet. But I think thanks to the availability of data analysis methods, we can start to think about how do we manage and make demand and supply meet. And that has already been an important topic of the conversation so far in our workshop. The other thing that's really new, as I reflect back to a workshop I participated a few years back when you invited me, Igor, that we really, have a whole set of tools, each one of them exciting and really quite amazing on their own, but collectively, some days I wake up with sort of a headache and think, how all of these sets of tools, methods, emerging technologies going to interact, and what kind of future are they creating for us, and how do we shape the future that we want to have? But it's of course terribly exciting what these allow us as people, these tools, these methods allow us as people to do. And so that's something that I reflect on a lot as well. And again, this has also been brought up so far. So as mentioned, we should be able fairly soon, hopefully, design our buildings for the performance we really want. And I'll come back to that, what that actually means. So I envision that a group of people designing different disciplines. I would still think we would be in the driver's seat there, but we can also talk about that. That we, a group of people, experts, would design a building or a set of buildings with data-driven methods by figuring out what performances they actually like from the past that exists, to then see what performances might be possible in the particular situation where that, say, if this is a building, is located in its socioeconomic context, geographic context, to then end up with the building that has the performance we want in the future, and to do so quickly and creatively and reliably. I think that's the vision we have, and I think you know that we can kind of imagine that we could get there, but there is many issues we have to solve, and I will touch on some of them. And I know many here in the workshop are aware of probably many others. But just to set the stage of how I see us working in the future, how I see us beginning to work, I wanted to put this slide here right up front, and also love to get some feedback whether this is the right way to think about this or we should approach this problem in another way. But moving forward with this perspective, that then begs the question, well, what performance do we want? So we need a language to talk about this performance. And then, of course, we need data. We need to make predictions and measurements. And I'll touch on those. And again, these has been touched on already. It's an issue that will stay with us for, I think, for some time. Then in terms of design, what do we need to design? And we have heard approaches to design the demand. We have heard approaches to design the supply already. We certainly need to design the particular systems in a building or in an energy system, buildings, neighborhood, cities, energy systems, or the user experiences. I think we need to design all of these aspects. And I believe we are really just at the beginning for some of those. Then we have seen in the last 2 years what happens if the world changes. So I want to report on a research project that one of my postdocs did in terms of studying the effect of the pandemic on the architecture, engineering, construction industry. And we also need to bring the knowledge we're creating to the next generation. And I want to share an initiative we started on teaching building energy efficiency. And in the discussion, hopefully we can then build on that and see where we go next, as was mentioned in the beginning of the workshop. So in terms of a language for performance of buildings, we propose such a language in this book that you mentioned, Igor, that well, we believe is the way to manage projects these days with a more integrated approach. I also love to get some feedback on that. But we organize this language into the 4 major stakeholders that we see in buildings. So first and foremost, the users. For me, that's really the most important, not that the others are not important, but it's the most important because that's the purpose of the building. And of course, they care about the health and safety, functionality, daylight access, comfort, aesthetics, acoustics. So it's categories like these for which we should have performance data and performance targets. Then you will not have a building unless it is buildable. And here we have the classic project management objectives for building: safety, schedule, cost, quality. There's also the operators, in especially larger buildings. Of course, in a home, user operators tend to be the same, but in a larger building, we have operators, and of course, they care typically about safety, energy, water, building operations, maintenance. So we also need to have performance data and predictions here. And then maybe I should change this to sort of the neighborhood, the wider context, sustainability, basically. How is a building enhancing or taking away from the economic, social, and environmental performance of a whole area, for example. So those we see as the main stakeholders. And for us, as we were working on the book, it was kind of sobering to write it down and realize just how many things somebody that manages a building, a campus, a city really should be thinking about. And so I wanted to offer this slide here as a way for us to put energy efficiency into a larger context of what somebody, as I mentioned, has to manage a building, really has to manage. One thing that has surprised me, I want to offer another framework, but it has actually surprised me because I haven't seen a situation where we have actually all of this data. But as you again think about what we need to predict, what we need to measure, what we need to manage, we need to, of course, manage the commercial energy, CO2, human performance related to our buildings. And for that, we need to pay attention to design and construction costs and design and construction duration. We need to pay attention to the facility maintenance cost, building operations cost, and the business operations cost. And we need to, of course, pay attention to the income from a facility or the value, and how long a facility is lasting. That is driven sometimes by actually really the durability of the facility, but also sometimes by the durability or longevity of a particular business purpose for a facility in the market. And I try to indicate what we sort of typically try to optimize, right? We try to minimize design construction costs. We try to minimize design construction duration. We try to minimize the business, building, and facility costs, and we try to maximize the income and extend the duration typically. But what I mentioned, what I'm surprised by is that it seems like a very obvious framework for us to think about the design and the different phases of a project, but also then the different cost impact in not only money, but other terms as well. But I have not found a single building where we actually have these data, even from building operators. And if I just have been barking up the wrong trees, then that would be fantastic to learn if you have case studies. Because unless we have these data, right, how can we make the trade-offs that we need to typically make in design as we look out, as we really shape the performance of a building or a set of buildings over their use span. And so unless we have these data and the methods for measurement and prediction, then how can we really inform the trade-offs that the people, right, that I showed at the beginning, have to make. And so just a few topics related to this are what performance metrics do we really pay attention to, and how good are our prediction methods, how well do we understand actually user buildings. There's many more, but these are a few that I or some of my researchers or some of my colleagues or collaborators have looked at. This, as you can see from the numbers, is a bit old, but I think it's still a relevant example to make this point quickly. These are buildings, retail buildings at various Disneylands around the world. And they were wondering which building operator should get a Christmas bonus. And if you look at a building on Hong Kong Disneyland on the left in blue and Walt Disney World in Orlando in green, both same kind of retail building, you can see that on a square meter, kilowatt hour per year per square meter basis, the bonus should go to the building operator in Orlando. Is far more efficient. But then when you look at the same buildings on a kilowatt hour per square meter per transaction basis, which connects to the purpose of the building, you see that the building operator in Hong Kong is performing much better. So this still makes me wonder, and I still have not found sort of value or purpose-focused metrics for built environment that are used widely or commonly. And again, if I'm misinformed here, have been working with the wrong people, let me know. But we still find largely these cost-based metrics, kilowatt hour per square meter. Both of those are cost related to the cost of the building. It costs money to build the square meters, and it costs money get the kilowatts. But here, right, the purpose of this particular building is to sell things. So a transaction relates much more closely to what the building is supposed to do. And so what I think is still the case, and I'd love to be corrected, as I said, that we tend to use mostly cost-focused metrics for building energy efficiency, and that we tend to focus on just one often, or just very few metrics, which then invites, of course, the gaming of the system. People are extremely good at that. They will figure out how to game a single metric focused system very easily. So I would really like to think about how can we bring more value or purpose-driven metrics into the building energy efficiency conversation. The other topic I mentioned is the performance predictions. I think this is probably well known, although again, if you have better news here, then I'd love to stand corrected. But a few years ago, we were able to work with a major owner operator who really cared to see how well their simulations, initial simulations, and then simulations that are based on building operations data actually perform. And you can see that for some buildings like 6, 7, 8, the predictions are pretty good relative to the actual cost, which is the red bars, but in others way off. And this has been reported in literature as well, as I'm sure you know probably better than I do actually. But it's still, I think, a very, very critical issue. This not out of the box fidelity of building energy performance predictions. Because if we cannot make accurate predictions rapidly, consistently, that is then too high in uncertainty, for example, to finance particular energy efficiency retrofits, etc. So I think this is a really critical point, because we allocate all resources on the basis of our predictions. And so we need to find a way to make them better. And hopefully some of you have seen better methods here. I mean, we looked into why is there the discrepancy. It's really comes from everywhere, from the accuracy of the data about the building to, of course, the assumptions in building operation, and the nonlinearity of a building, of its energy performance, and so on. The other thing we're trying to understand is the building occupancy. That is, at least in the North American context, of course, very heavily related to privacy issues. And so this is work by Andrew Sonta, my colleagues Andrew Sonta and Rishi Jain. Rishi at Stanford and Andrew about, I think, to be at APFL in Switzerland. And they developed a method to understand how an office building is being used from plug load data, which is a chance we can get. And so what they found is actually that they can infer pretty well from looking at the plug loads and how they are changing over time, how many of the people might actually be hanging out together. I mean, it's not certain, etc. But we were able to get a ground truth in some buildings where we were able to observe what was really going on and then correlate it with the plug load. So it looks like a very promising method to study the plug load at each desk and realize, okay, this person is sitting at a desk or this person is not at the desk, and then correlate that with the plug loads of other users, and possibly think about, once we have this data, whether there could be an optimization in the layout of the building in terms of where people sit. And this is a bit of a conjecture, but according to the simulations they did, they saw a 5 to 6% improvement potential from a better layout for the particular case study. So I think this is another important question, is how are the buildings actually used, right? If we want to get to a value-based metric. And again, would be good to discuss how we get these data and what are other methods for getting these insights. And then the other part that we work on quite a lot in many areas is sort of self-managing or autonomous buildings. That's not only on the building side, it's also in construction and many areas. And I'm wondering how far out this idea of self-managing buildings, Igor mentioned it, really is. As we looked into this, and it's a little bit too detailed probably to go through here, but looking at how we process data, generate a digital twin, develop an optimization strategy, analyze building performance, visualize results. We see quite many areas where we have to make significant improvement in terms of understanding data quality, for example, validating a digital twin, and connecting it automatically with data feeds, agreeing on the performance that should be analyzed. Back to the previous discussion I had. And then, and who needs to see the results, who intervenes when, and so on, if somebody needs to still intervene. But I think this is, for me, for us, it has been a really good way of showing or understanding where are we in all of these areas with the current methods, by trying to automate the operation of a building fully. It forces us to be really clear on these and probably more issues. And that has been a very useful research method for us. But I'd like to actually discuss, do we really want to have self-managing buildings? Why not? I mean, it seems kind of like we would want to, but maybe we should think about that a bit more. And how far are we to actually having them? So I've already alluded to these discussion questions. Are there value-focused metrics that are commonly used? If not, how could we bring such metrics to practice? Is there an organizational case study that has data for all of the parts of the obvious, I think, cost-value framework that I showed? And the question about self-managing buildings. So I know this is a lot of topics, and obviously we will see where we want to take it in the conversation. So I want to quickly share a couple other efforts, recent efforts that have happened. One is a study that Natasha Mrazovic, one of my postdocs, has done in the pandemic. As she was at home, locked down, she said, okay, I have lots of time to look at things, and I'm just really curious to study how people in webinars, in reports, in all kinds of publications talk about the effect of the pandemic on the architecture, engineering, construction industry. And so I don't really, still not quite sure how she did that, but in some months she looked at up to 900 references in terms of different publications related to impact of the pandemic. Eventually developed 12 categories and 22 subcategories, with building operations being one of the 12 categories. Others were impact on construction and so on. So there's reports published on this on our website, but I asked her to pull out sort of a bit over time what she saw as the major trends in all of those references and sources related to building operations and energy efficiency. So what she found early in the pandemic, this was only going to be a month, and we didn't really have to do too many changes, although health and safety priorities were starting to emerge. And so we needed to develop these procedures, not surprising. Then, as we realized this was here to stay for a little bit longer, what was reported as that, what she found is that people reported that buildings are using more energy than pre-pandemic, even though they were not actually hardly being used. And basically this health and safety issue, there's a quote from one of the sources. Energy efficiency was the topic to discuss before the pandemic, but now we're using more energy to make buildings as safe as possible. So energy efficiency was like an afterthought. We made operational changes that consume more energy than before. All our assets are open nonstop, though in some only essential workers are working. Ideally, in a year or so, we will go back to what was before the pandemic. Again, it's interesting to look back and see the sort of predictions at the time, but I think this is helpful for us to think about too, as we think about what do we want to do in the future. And sort of reflection now is that before COVID, we really paid attention at what we saw on energy efficiency, using less energy. But now that gets balanced with the health and safety. So I'm curious how you experience that in terms of your building performance or those of your clients or that you research. And yeah, I think the other topics previous speakers have already mentioned or have already been alluded to in terms of technology. The challenge of managing buildings, how do we create the knowledge for our facility managers? I think people are struggling. What we see is people are trying to figure out what is really sort of the normal future operation. So I'm curious how our findings, that basically based on what was discussed in the literature and in the industrial professional literature, how do those compare with your experiences? And what should we actually take away in terms of this disruption we had? I think it made us rethink our assumptions. At least that was a very useful insight for us. And then I want to sort of share one last example of recent work we have been doing, focused on the education. The Stanford Building Decarbonization Learning Accelerator. It's kind of a mouthful, BDLA. But I'll try to quickly motivate it and share where we are, and then curious to see whether you think this is indeed a good effort, good way of spending our time, and if so, whether you would like to support it. It's really mostly led by Peter Rumsey and his colleague Avril, and I'm the main guy at Stanford. And but quite a few others have supported us in this effort. I've mostly worked with Nea Malou at Harvard University. I'll come back to that. But as you know, now most of the new electricity sources are from renewable sources, which then enables a rapid decarbonization. But what we see, AEC, architects, engineers, construction professionals at scale are rather slow to adapt. So how do we educate them so that they can produce decarbonized buildings? When we saw this, and a student of mine did a case study over the autumn quarter with several developers who are very successful, well-meaning, and he said basically he was shocked that energy efficiency gets discussed, but at the end of the day, it doesn't quite really make it to the forefront. Other topics, other performance aspects trump it. So that's why the language that I suggested at the beginning, I think, is important. Reflection that Peter had is that based on his analysis, the average American is sort of responsible for about 1.2 thousand metric tons of CO2. But the building designer over his or her career affects, 1.15 million metric tons through the decisions they're making. So I think that was quite a, for me, really interesting way to look at this. And sorry if I'm late to the party here. Just the impact, right, building designers have, hence the title of my presentation. And then hence the importance of trying to educate a few students to then hopefully affect the professionals when they go into those practices. So the goal of our BDLA effort is to really help other faculty members bring learnings about building decarbonization and strategies for building decarbonization to their students, so that as part of getting these methods into practice. The initial focus is on working with faculty at HBCUs, because the HBCUs are in areas where there is still a lot of fossil fuel being used. So trying to get them into practice and bringing those methods into practice, I think is critical, also from a social justice perspective. And so we have mostly worked with these universities, actually mostly with Howard University, with Nia Malou, where we helped deliver what we believe is the first architecture course that was fully dedicated to building decarbonization last summer. So what is this BDLA? Basically providing teaching resources for college university professors in architecture, engineering, construction management, in terms of presentations, case studies, videos, assignments, and support. So it's accessible through our website, and in terms of access to slide decks and so on, and also in terms of case studies. One of the main case studies was the AIA headquarter renovation, or is the AIA headquarter renovation. I think that's well-known effort. I think there's maybe a little bit here too much into the weeds, but where we have materials now, and obviously we need a lot more. So I'm wondering, is that decarbonization of buildings we need to focus that makes energy efficiency widespread? Is that finally sort of the word that will get us there? I'm curious what you think. This initiative, do you like it? Should we keep doing it? Is this a good way, as I said, to spend our resources? And if so, is there a way for you to support it with a case study, money, whatever makes sense in your case? So yeah, this is one of the recent efforts we're doing related to energy efficiency. So broadly, overall, the question that I have been reflecting on is which sustainability solutions are globally scalable rapidly? This sort of came to me, although I started to think about this in the context of a couple recent conferences. In one, methods for retrofitting homes for greater energy efficiency were produced in the UK particularly. And then I calculated, to reach the targets, we need to, I think we have something like 3 minutes to retrofit every home. So it doesn't appear to be rapidly scalable. So something is missing still. In the other was a presentation by a major developer of multifamily housing projects. And they pointed out that the building was done in timber, and that was already alluded to as well. And they pointed out that it took the North American forest only 8 minutes to grow the timber for that building. And then, so I also then back of the envelope calculation showed me that that was really useful information, because we could then calculate, a colleague and I then calculated that, okay, current timber supply could be used to build a third of the buildings in North America. So many more than we do today, but certainly not actually scalable. Well, because that would also mean we stop making furniture out of timber and things like that. So that obviously not quite feasible, but anyway, I'm just curious what was the limit at the moment. Yeah, these sort of examples show, so we see a lot of hype and opportunity with better solutions, but then when we try to see how they actually scale, are they rapidly scalable? More often than not, I find no. But this is just sort of initial reflections. But this is a topic that I think would be very useful for us to think about. Which are the sustainability solutions that we have could really be scaled globally rapidly? Do we have the resources? Do we have the skills? Do we have the way to disseminate the knowledge, etc.? So as I mentioned, lots of questions for my presentation. but hopefully the glimpse in our current work and issues we try to deal with, and then the questions are helpful for the workshop. Thank you, Igor.
Thank you, Martin. Thank the speaker. Thanks for that very wide-ranging discussion that emphasizes how much of the energy efficiency questions are actually tied to many other questions, including the ones that happen at the design stage. We have plenty of time for discussion, so we do have a few minutes for questions if anybody would like to ask right now, either panelists or participants. Let me see. I'll start with a brief one. On your graph of predicted versus performance, that was prediction based on the design calculations, right? The energy.
So there was two. One was basically the initial design. Those tended to be even worse, and then we another one we made a bit later, where we had better data about the operation of the building.
So it seems like the situation, since I last looked at the problem, it seems that the situation didn't change that much. I mean, you pointed this interesting work on measuring occupancy from plug loads, and in some work that we have done, it really does turn out that one of the major issues that is missed or changed, really, so it's not really the fault of predictors, is the usage. The occupancy changes, and it's very similar to that point that Marianne did, which is, look, you retrofit, you change the use of the building, and the predictions that you had from an upfront piece of software are just out the window. So that's monitoring. I think keyword monitoring, I would say, is really something that we need to enhance on. And Marianne had a question.
Yeah, Martin, I really enjoyed your talk. It's a good complement to the one I gave, because I was talking a little bit more about the grid and controls, and thinking about design is really important. I keep in touch with Peter Rumsey. He's actually lives a block and a half from me, so I see him and we chat, and great work you're doing with him. My question's about carbon metrics in the building sector. And you talked about design costs and operational costs, and getting people to think about carbon is a really different thing, whether it's the embodied carbon or the operational carbon. How do you think we get the buildings community interested in that issue? And if we wanted a carbon benchmark, do you think AIA is interested? How do you think about sort of the decarbonization pathways and helping the architects and engineers and facility managers get involved?
No, I see a lot more attention to this term, so it seems to stick more. I have to admit, decarbonization is not totally my favorite term, because we wouldn't have a building without carbon, obviously. So it's a bit strange term, but I understand we're talking about the fugitive carbon, as Bill McDonough talks. But my experience, it has been sticking more, and so I think in that sense I do see a possibility, and the people do understand, as you said, the embodied carbon and the operational carbon. I think that's still a level where people get it, and it seems like this could be an easier approach, as you said, to benchmark, because we could, energy efficiency was always, at least I found in the people's eyes glaze over too quickly. Not that they wouldn't want to be efficient, but
Yeah.
when you get into a design meeting and there's the multiple disciplines there, and they try to juggle these many performance aspects, it becomes difficult. And the project teams, I mean, when you visit the building I'm in, I think is an example. We had great aspirations, and I think it's overall working quite well, but it took a lot of effort to make it work well. So it's not really scalable.
Yeah.
But embodied carbon, operational carbon, I think are numbers that could possibly socialize, but I think it would take a combination of ASHRAE, AIA, but then also we have to, maybe that's where, now that I think about it, AGC, you know, the builders have to be on board too, because I think my reflection is that's where things fell apart in our building, because people have, project teams have like if you come and propose something that has a chance of the building falling down, you know, as a change, they will react and say, no, you're crazy, you're not going to do that. We have learned that, but we don't have the same reflection when it comes to energy efficiency or decarbonization methods. We make cost-cutting methods, we make cost-cutting changes. We think, yeah, that's okay. But before we know it, we made the building much worse.
And if you don't like the term decarbonization, is there another term that you think that you like better?
No, yeah, so that's why I keep using it also, right? And that's why I'm part of the decarbonization effort. No, I don't think it's the train has left the station. I don't think we can change it anymore. But I just wanted to point out that, yeah.
Okay.
100% happy, but yeah, I mean, what do you think about that term?
Well, I agree. So, you know, I'll tell you, some of the leadership at the Department of Energy is like, we don't do energy efficiency anymore. We do decarbonization. Mm-hmm. And that, you know, there's so many reasons why energy efficiency matters. It's because, you know, carbon is not linked to bills. That's the hard thing. Mm-hmm. You know, it's not necessarily economic. And so how to think about helping people understand, you know, if you think about the climate agenda, it is urgent. And so I think we need to try a lot of things. I think that's the thing is, I think that, again, the people on this call have an opportunity to really try to amplify these messages and accelerate the innovation, because it's pretty darn urgent.
Yes. Yeah.
So we try everything.
And Tim had a great point, which is humans are also carbon-based, so decarbonization might not be the best term. I had Dan and Mark literally at the same time. I think I'll ask you to agree on who wants to go first.
Go ahead, Mark. Thanks, Dan. This is quick. Are there, you kind of, a lot of your perspective was sort of the US, and then to some extent occasionally in Europe. And I just wondered, you know, and again, I'm a computer scientist. I'm from another part of the world here, another part of the technical world. How much of what you talked about is applicable in places, as John mentioned, like China and India, you know, the developing world, and you know.
Yeah, I think that's partly, I mean, it's partly applicable, partly not. I'm mostly coming from there, and I think that's Marianne's point as well. It's urgent to identify the particularly bad practices and make sure that they don't get implemented in places like China, India, Africa, where, right, a lot of infrastructure, a lot of buildings are being built. But then others have done, I remember, I don't know whether it was I think a conference at Stanford a few years ago. We had a research from China, and others here may be more up to speed on that and up to date. But basically he pointed out actually Chinese building is more, multifamily housing project was more energy, dramatically more energy efficient than, because of the lower income of the people, largely, than the US, because they would just air condition a room. The rest of the building was quite warm. And in the US, you just air condition the entire building. But as China became more affluent, now we're starting to air condition entire buildings also. So that's where, so this is like an example of where we see this trade-off between overall comfort and ease of operation in some way, distribution of that operation with then energy efficiency.
Okay, thanks.
Those are some great points. There are fan coils in every room, and things are very efficient. Then
Yeah, so
we have a question then from one of the attendees, but then first.
yeah, so there has been a multi-million, arguably multi-tens of millions, maybe hundreds of millions of dollars business in over the last 20 some odd years, or maybe 20 years, in corporate carbon mitigation efforts as part of corporate social responsibility plans, okay? And you get the report from the multi-billion-dollar international corporation about all the stuff that they're doing to mitigate carbon and how they're limiting business travel. And you've got scope 1, scope 2, and scope 3 emissions and all that kind of stuff. And arguably, having participated in a number of these things over the years, the approach to the built environment is typically very superficial and very naive, not very technically good. And you know, I think there is room to make that better and try to continue to tag along with this, you know, arguably public relations motivated sort of trend of large businesses. If we can sort of inject ourselves into this process with good technical input, there is the opportunity to achieve something, I think.
Yep. No, thanks. I totally agree. It's a much better articulation of the point I made before in terms of, I see that this decarbonization is taking, and I think this is one of the reasons, at least for the time being. Yeah, no, I totally agree, Daniel.
Maybe the last one is a question from Andrew in the audience. Is there documentation about increase of first costs, D&C, for building performance versus life cycle costs? And is there work to show and educate developers and large portfolio owners, operators about business case to justify first cost premium for high performance?
So this comes up. So in all the companies I have a pleasure to work with that make buildings, this comes up all the time, and at least I have not seen such a study. I've seen many of anecdotes, you know, people saying this is 2% more or 5% more, or no, if you really pay attention, it's actually not more. This is the anecdotes I've heard or seen, but then and this is a good point. I think if we can if we could really show this conclusively, we could influence the development of buildings much more.
And this harks back to one of the salient points that you made nicely and strongly, and that is that reduction of risk for investment in energy efficiency yep. is a blockage that precisely those kinds of studies could unblock. It's really a very, very serious problem. But interestingly, that harps back to some of the technical aspects that are pretty deep, because those kinds of verifications, validations, monitoring they're not exactly easy to do. And you mentioned that when you compared, who should get the Christmas bonus. So what exactly is the metric? And so now we're getting to fundamentals, which is kind of interesting. And Tim, because you're the next speaker, but also you're noting something, so maybe you can tell us, and then I'll have the pleasure of introducing you next. But thanks Martin again.
I'm just running over my own time now, so that's okay.
We put plenty of time in the discussion, so we've allowed a little bit more time for basically the first part of the discussion. You have all of your time in the presentation that you want.
If I can just very quickly comment, sorry, Tim. I really like this summary that I think you hit the nail on the head, Igor. And this is what actually does excite me about being here today and working on this today is I finally see really this connection between the technical, the conceptual underpinnings and the global impact and business value. And I think that's where I think the technologies do make a difference in our ability to get the data, to validate our assumptions, our methods, and then connect them to this problem of like taking out the risk for energy efficiency investment, for example. And
that's Tim's point, a certain case. Just a note around lack of standardization around GHG accounting, right? Hard to compare.
Yeah. I mean, I think I'm just repeating what others had already said, but there are big claims out there in terms of meeting these net zero targets and around decarbonization, but all the methodologies are non-standardized. People are using different approaches to make these accounting calculations. So we really need to do some work, I think, around standardizing these methodologies so that we can compare on a more even platform what people are doing.
And final thing, because it's from the attendee, Scott said, how about funding a consumer reports type organization that review energy and carbon metrics in buildings? Data gathering will be time consuming, maybe awards for some. It's an interesting idea. So maybe let's leave it there and discuss it a little bit later, because it's a broader point, but a very nice point.